All right, so now we'll quickly walk through how you should get the information that you need to answer the key question. This is for slide 7. So the key question here is, it's about kinetic energy. So how do the speed and mass affect the amount of kinetic energy stored in the system? All right, so when you run the simulation, you want to pay attention to the speed and the mass, change those two things independently, one at a time. So do the speed and then do the mass. And for each of those, you want to measure how the kinetic energy is stored in the system, how those two changing either the speed or the mass change the kinetic energy. All right? So let's go back to the simulation and check it out. First of all, let's read the questions. Open the the instructions. Open the energy the simulation. Click on the intro version. Do all the boxes in the check all the boxes. The same thing. And we want to figure out how the speed and the mass affect the kinetic energy. So let's go there and do that. All right. So let's restart the skater so everything is hunky-dory. All right. We have a slider here that says, we can make the skater teeny or we can make him huge, right? And then we also are looking at how the speed changes the kinetic energy, right? All right, let's just try running it. Let's go to the extreme. He's teeny tiny. So here we have the total amount of energy in the system. It's all potential at this point. Is a relatively small amount. And let's see what happens to the kinetic energy, and let's also pay attention to the speed. Let's let it run for a little bit and just sort of see what happens. Okay, so it goes up. Basically the same thing. Friction is still 0. So it's going up, down. The amount of energy is there. So the speed, when the speed is maximum, the energy is also maximum. Let's just see if we can show that. Oops. Well, kinetic energy is maximum when the speed is maximum. I'll let him go past it just a little bit. Oh, I let him go past it again. But even so. So when the mass is small, the energy is small. When the speed is high, the energy is high. Let's keep going just a little. We'll pause it up there. Just step up to the max. Okay. When the speed goes down to 0, which is there, the kinetic energy is 0. And when the speed is maximum, see, it keeps going up. Well, I can't go backwards. But now as the speed goes down, see, watch the speed going down, the kinetic energy starts to go down and potential energy rises. All right? So you would take a screenshot of whatever, states, whatever situations you think will answer the question. And so this is when the guy is small, right? So let's just change that real quick and you'll be doing a different scenario here. If you look at what's happening to the total amount of energy in the system, right? When he's huge, there's a lot more energy in the system, both potential energy and kinetic energy. Let's just keep going. So let's step all the way up. It's going to go to 0. It looks like he's going to fall off, but he's not. And so everything's potential, and none's kinetic. And it goes back down. So the same situation applies here. When he is huge, it's just that the absolute number, the absolute amount of energy in the system is bigger when he is huge compared to when he's tiny. So if I'm thinking how I would characterize, how I would capture this information for this report, I would probably say, okay, I want when he's huge, when he's all kinetic energy, and then also huge when he's all potential energy. And that'll show us that the amount of energy in the system is constant between those two situations. So this screenshot when he's down here, and then a third screenshot when he's up here and he's tiny. Look what happens. It's just the absolute amount of energy in the system changes. And then the fourth screenshot when he's all the way down here. Right? And then pay attention to the speed, because that's part of the question that's being asked of you. I'm not going to go into more detail about this because that's part of the exercise for you. But that should give you an idea of the information that you would like to capture and how you ought to do the screen captures and so on. So back to slide 7. What are your observations? I would say when he's very small, the total amount of energy in the system is small. And when he is going at the highest speed, all of his energy is kinetic energy. When he is at the top of the ramp, all of his energy is potential energy. So his kinetic energy increases with increased speed, and his kinetic energy increases with increased mass. And you've got the small guy at the top of the ramp, at the bottom of the ramp, the big guy at the top of the ramp, and at the bottom of the ramp. And that should be enough information, I think, to answer this question. So write your observations here, just what you observed again. And then in the next slide, you'll do your claim and your evidence again.